Hello guys, I'm Alukoshao Enoch. Welcome to my math tutorial on coordinate geometry. In this tutorial, I'll be taking a look at GCSE, IGCSE, IB, PSAT, and AISL exam style question. And this very question is an excerpt from Additional Mathematics 0606, October, November 2011, paper 2-1. So let's take a look at the question. The point A coordinates 1, 4, B with coordinate 3, 8, C with coordinate 13, 13, and D are the vertices of a trapezium in which AB is parallel to DC, and angle B, angle bad guys, is 90 degree. Find the coordinate of D. So guys, let's just to get started with this question. And the first thing is, let's just work with the coordinate of points A and B, and from this coordinate we can find the gradients of this of the straight line. So the line joining points A and B. So let's go ahead and do that first. Okay guys, don't forget how to find gradients of a given line. So for AB now, let's denote that with MAB, M subscript AB. So and the formula to find the gradient is given as change in y divided by change in x. That is y2 minus y1 and divided by x2 minus x1 minus x1. So and if you look at the coordinate we have now, okay, so the first one, this A, you can label 1, 4, x1, y1. That is the coordinates for point A. So this is your x1 and this is y1. Then for point B, and that is 3, 8. What am I writing? 3, 8. So that would be x2, y2. x2, y2. Guys, don't forget this is actually x1, y1. Sorry about that. Okay, and this is point A. So the distance between the 2 points, that's straight a line is distance between 2 points. So we want to find the gradient of the line AB. So change in y divided by change in x, that is 8 minus 4 divided by x2 is 3, the next one is 1, 3 minus 1. Then that will be what? That's 4 over 2. So in conclusion, the gradient of line AB is 2. So gradient of line AB is 2. Okay, and before I continue, let me quickly make just a quick one. And if you have if you are given 2 lines and the 2 lines are parallel to each other, then the gradient will be equal to each other. But if you have 2 lines and they are perpendicular to each other, then the product of the gradient should give you -1. Don't forget that. Okay, so let's continue now. And we're told that for this now, we're told that the trapezium in which AB is parallel to DC. So we can go ahead and find the gradient of DC now, and since DC is parallel to line AB, then the gradient of AB and DC will be the same. So we can conclude that the gradient of line DC is also 2. So let me just put that here. So since I don't need to write everything, so but let me just put that. Since line AB is parallel to line DC, line AB is parallel to line DC, then the implication is such that the gradient of DC will be the same as gradient of AB. And since gradient of AB is 2, then the gradient of DC also will be 2. So that's good. So I can put that also in the rectangular box. Okay, now what I'm now going to do now is I need to find the equation of the straight line DC. So let's go ahead to find the equation of the straight line this CD rather. Okay, or DC, CD, or DC is okay. So now, but we have the coordinate of C. The coordinate of C is given, and since I'm looking for the equation of straight line, CD Let the equation of this line CD be denoted by y. So we have y equals to, or y minus y1, sorry about that. So y minus y1 equals to m into x minus x1. Okay, and this time around we want to look, we are looking for equation of the line this CD, and so this will be our x1 because it's CD. So this is x1 and y1, but we don't have the coordinate for d, and that could have given you your x2 and y2. So but we can go ahead and find the equation here because we are looking for the, we are asked to find the coordinate of d. Okay, so let's just go ahead and do that. And before, okay, so that is y minus y1 is 13 equals to the gradient of CD or DC is 2, so that will be 2 into x minus x1, and x1 is also 13. So I can open up and complete the stuff now. Better still, I'm going to have y equals to, if you open up this bracket, you have 2x minus 26. If you move minus 13 to the right hand side, that will be plus 13. So minus 26 plus 13 will give you minus 13. So the equation will be 2x minus 13. So 2x minus 13 is the equation of the parallel line, the line DC parallel to AB. So let me put that also in a square box or rectangular box. Sorry for that. Okay, now if you now look at this next condition now, what to that angle bad is 90 degree. So since angle bad is 90 degree, that is angle BAD is 90 degree. So angle A is 90 degree. So the implication of that is AB is perpendicular to AD. Okay, so meaning that AB is perpendicular to AD. Now since if AB is perpendicular to AD, and don't forget that when you have two lines perpendicular to each other, then the product of their gradients will give you -1. And the gradient of AB is 2. So we have 2 times the gradient of AD. So let's tag that MAD. Should give me -1. So then from there, then I can finish up. Then the gradient of line AD will be -1/2. That will be minus half. Okay, let me now put that in square bracket too. Or in rectangular box, better still. What am I talking about in rectangular box? Okay, now so I have this equation is equation of line DC, and it's such that the line DC is parallel to line AB. Then now I need to get the equation of line AD this time around, and line AD is perpendicular to AB. So now let's go ahead and use this same formula: y minus y1 equals to m into x minus x1. I don't need to quote this again, but this time around this is AD. So therefore I'm going to use this x1 and y1. When we're working with CD, then you use your C as your x1 and y1, but this is AD, so my x1 and y1 will be 1 and 4. So let me just go ahead and finish up now. So y minus my y1 will be a coordinate, so that is 4 equals to the m is the perpendicular, so that's gradient of the perpendicular line AD, so that's minus half into x, and the x1 here is 1 -1. So I can open up the bracket now. Then I have y minus 4. Okay, y minus 4 equals to minus half x plus half. Am I correct? Minus half x plus half. Oh, I didn't finish up this. Okay, let me just undo that. Is it going to waste my time? Okay, so minus half x plus, because minus half times plus 1 will be plus, so plus half. Then I want to make y solve your formula. If you move 4 there, so that will give you what now? 9/2. That is 4.5. So y will give you minus half x plus 9/2. Okay guys, let me just put this also in a rectangular box. So now I have two equations now. Equation of line parallel to AB and equation of line perpendicular to AB. So when you solve the system of equations simultaneously, don't forget that I have CD here, then I have AD. So when you solve the system of equation simultaneously, you're going to have the coordinate of D. Okay, so I need to go to the next. So the equation I now have is I may need to rewrite this so that I have something like 2y. Let me just do that here. So if LCM here will be 2, so that will be minus x plus 9. But let me just leave it for now. I'm going to do it next. So let me just, I need this information. So I just want to carry to the next page. Y equals to 2x minus 13 and y equals to minus half x plus 9 over 2. So let me go to the next page because I don't have space to complete the task here. Okay, now so the equation of the line parallel to AD, and that is y equals to 2x minus 13. Then the equation of perpendicular to the line AB, that's line AD, that is y equals to, I think, let me check. That's minus half x plus 9 over 2. Minus half x plus 9 over 2. Guys, I don't want to work with rational number, so let me just find LCM here. So this equation 1 is good. I'm cool with this one, but let me go ahead and do this now. LCM here is 2. Okay, so I have minus x plus 9 equals to y. So when you cross multiply, then I'll have something like 2y. Guys, I want all the variable to be on the left hand side. So when you move this one, that will be plus x equals to 9. So this is my equation 2. And my equation 1, 2, I would like all the variable to be on the left hand side. So I'm going to write this one as y minus 2x. So let me just write it here. I don't know, it's not a bad deal. Oh, okay, guys, let's just do this so that so let me write equation 1 before equation 2, but doesn't mean, but you guys are very sensitive, so let me just go ahead and do that. So equation 1 now, all the variables should be on the left hand side now. So y minus 2x equals to minus 13. So that's my equation 1. And my equation 2 is this one here, and that is 2x 2y better still plus x equals to 9, equation 2. Now I'm going to solve the system of equations simultaneously now. So I would like to eliminate x. So to eliminate x, you just multiply equation 1 by 1 and multiply equation 2 by 2. So because of space here, I don't need to write everything here, so I know what I have already. Guys, let me just make it here. So now here now I have y minus 2x and minus 13. Yeah, I'm going to have 4y. I need to write that. Let me just go ahead and guys, I need to write everything. Guys, I don't need to write everything, just follow. So this will be 18 here. Okay, let me just go ahead and do that because this is just the first question. I don't need to rush over it. So 2x equals to minus 13. That's equation 1. When you multiply by 1 is a multiplicative identity, so it's not going to affect the variables and the constants. So then 2 times 2, that's 4. So this will be 4y plus 2x. 2 times x is 2x. Then 2 times 9 is 18. Equals to 18. So then just do sum the equation. Sum equation 1 and 2 together. So I don't need to write equation here. So for this will give me 5y. Minus 2x plus x, that will give me 0. Then this will give me 18 plus minus 13, that will be 5. So therefore, what am I doing, guy? So this is 0, guys. Let me just write plus 0. So from there we see that 5y equals to 5, and therefore y equals to 1. So that is the coordinate of y sorry, y coordinate for D. So for point D, then substitute y equals to 1 equation 1, or better say in equation 2, either way, but I'll prefer it in equation 2 so that I can get x. So then I have 2 times y, that is 2, so that will be 2 plus x equals to 9, and just take 2 to the other side, then x will give you what? So x equals to 7. Okay guys, so from here now the coordinate of D is x comma y, so that is 7 comma 1. X comma y, that is 7 comma 1. Okay, so that's cool. So let me go back to the question. So the question asks us to find the coordinate of D, and that's all guys, that's all. Just find the coordinate of D. That's all, nothing to do again. Let's go to the next question. Hope that is clear guys. So let's go to the second question now. I don't know, let me just clear the page. Let me clear this page and clear this page too, because I'm through with the question. Okay, everything, let me clear this page too. That's why it's a video guys, you can just rewind and go over it again. So let me just insert the next question now guys. Because of our time, I have a lot of questions to solve, a lot of questions guys, you can see, and I'm going to divide this video into 2 sections. So the first 2 questions, that will be part 1, then the last 2 questions will be part 2, so that I can upload it on YouTube. So let's take a look at the last question. I'm going to make another video for the the remaining 2 questions. So let's take a look at this one now here. So we have just a minute please, just a minute. Let me quickly do something. Let me just pause it. Okay, so let's take a look at the next question now. This one's the diagram show a trapezium ABCD with vertices A 11,4, B 7,7, C -3,2, and D. And the side AD is parallel to BC, and the side CD is perpendicular to BC. Find the area of the trapezium ABCD. So we have to find the area of the trapezium, and if you look at this one here, the coordinate of D is not given. Okay, so the first note here now, the first key note here, we need to, so first thing for us to first information here is that we have coordinate of A and B, and we have coordinate of C, but we don't have coordinate of D. Then secondly, we are told that AD is parallel to BC. So since AD is parallel to BC, then we can go ahead with the coordinate of BC, because we can't find we can't do anything with AD because the coordinate of D is not given. So we can go ahead with the gradient of BC. Then since they are parallel, then the gradient of the 2 line should be the same. So let's go with the gradient of BC now. So the first question, the first step to solving this problem is to go ahead and find the gradient of line BC. So this is line BC here. So let me put that in square box for a better understanding. Rectangular box. Okay, so this is BC. Because we have all the information about point B and C, so we have the full coordinate there. I can't do anything with AD because we don't have coordinate of D. So and there's relationship between BC and CD. So let's just go ahead with this one. So there's relationship between AD and BC. So let's go ahead with this. So the first step here now is to find the gradient of line BC. So don't forget that I'm not going to write that again because you understand that from the very first question. So change your y divided by changing x. That's how to find the gradient of a line. So I'm going to represent the gradient of line BC as MBC. So M subscript BC. And that's change in y divided by change in x. So let me just write it as change delta y. This additional mathematics guy, divided by delta x. So change your y divided by, that is y2 minus y1 divided by, guys, this is not increment guys, so just use this, not differentiation. So change your y divided by change in x. Okay, so this is BC. So the x1 coordinate is 7, x2 coordinate is 7, x1 y1 is 7 7, then x2 y2 is minus 3 2. So y2 minus y1, that is 2 minus 7. So 2 minus 7 divided by change in x, that is minus 3 minus 7. So minus 3 minus 7. So 2 minus 7 will give me minus 5. So that's minus 5 divided by minus 10. So minus 5 divided by minus 10, and that will give you what? Plus 2. What's going on? Why are you doing that? Ah, okay, sorry about what? Don't stop that. So minus 5 divided by minus 10, and that is 2. So m subscript bc, that is the gradient of line bc, is 2. So gradient of line bc is 2. So I can put that in a rectangular box. So let's keep that. So gradient of line bc is 2. So just keep that for now. Okay, now since the based on the example, the side AD is parallel. So if AB is parallel, if sorry AD is parallel to BC, the implication is that the gradient of the two lines will be the same. So so let me just write that. So the condition, if you have two lines parallel to each other, that is BC, we have the gradient of BC already, is parallel to line AD, then by implication the gradient will be the same. So I can conclude that the gradient of line AD is also 2. So gradient of line AD is 2. So let me put that also in a rectangular box. Now there is no problem again. The best thing for me now is just to go for the equation of what are we asked to find though? What am I doing? Oh my, this is a serious mistake. I'm sorry about that. Okay, this is minus 5 over minus minus 5 over minus 10. That is 1 over 2. So I don't need to waste my time. I'll just can I just clean this? So this should be half. This should be half, not 2. And this should be, oh, this board. Because I opened 2 pages to get. Okay, so this is half here. Because minus 5 divided by minus 10 is 1 over 2. So this is actually 1 over 2. So the gradient of line BC is half. And consequently, the gradient of MAD, that is m subscript AD, is also half. Okay, now so I can go ahead with equation of straight line AD. So we are looking for equation of line AD. Now this is AD. AD meaning that my x1 and y1 will be 11 and 4. Okay, so because it's AD, so let's go ahead with the equation of line AD now. So equation of line AD, let me just write this here. This is equation of line AD. But I don't need to write this AD, so let me just put this. Well, I want to write the y, just y. So y minus y1. So our y1 here is 4. So y minus 4 equals m. M is half into x minus x1. Now x1 is 11. So let me just finish up. Then here I have y minus 4 equals to half x plus half x minus 11 over 2. I don't know, the best thing for me here is to, let me just go ahead and finish up. The LCM here is 2. So I have x minus 11, then that's y over 4 equals to that. Sorry, y minus 4 better still. Then cross multiply, so that will be 2y minus 8. If you cross multiply, 2 times y is 2y. So what's going on? So 2y minus 8 equals to x minus 11. So then now I'm going to collect like times now. X minus 11. Why is it quite because of that second page is just trying to come up every time. Okay, x minus 11. So I want all the variable to be on the left hand side and all the numbers on the right hand side. So this will be 2y minus x, and if you move minus a to the right hand side, that will be plus it. So minus 11 plus 8 will give you 3. Sorry, that will give you minus 3. Undo. So that will give me minus 11 plus 8 will give me minus 3. So the first equation I have here is the equation of a line AD parallel to BC, and that's that. Okay. So let me just put that in a rectangular box, guys. I don't have more space here, so I can go to the next page that is trying to come up every time before now. But before I go to the next page, let me just read on AD is parallel to BC and the side CD is perpendicular to BC now. So the first thing, AD is parallel, so the equation of parallel line to AD is this. Then I will go for equation of the perpendicular line to BC now. So since it is perpendicular to line BC and this is half, let me just do that here. Let me just get the gradient here. I can still manage this space here. Let me just demarcate here. So let me just do that so that what I want to work with next page is just to solve the system of equations simultaneously. So let me see if I can get the equation of perpendicular line to BC here. So for if two lines are perpendicular to each other, then the product of their gradient should give you minus 1. So by implication, I don't want to waste much time here. The gradient of line because this is a side CD. So gradient of line CD now is perpendicular to BC. So since it's perpendicular to BC, that will be minus negative reciprocal of the gradient of the of BC. That is minus 1 over half. That's what we are going to update. Okay, I know something like this is likely going to happen. So at this point, my e-board is misbehaving. Let me just quickly, because I don't want to lose track of the question I'm solving. Let me just make use of my light shot now, so that I can take a screenshot of that page and continue from there. Okay, guys, sorry about that. I just need to quickly do this, but I can't afford to start all over again. That will not be nice, guys. So I'm going to take screenshots now of this page. Oh, I don't know why it's taking time to do this. Or did I still not activated? Let me bring it out again. Light shot is active now. This is why is it not coming up? Well, this is not where I want to use it for. Okay, I want to use it here. So can I take print screen now? Okay. I think let me just quickly pause the video, guys, so that I don't waste much time with this. Let me just pause the video. Okay, guys, I'm sorry about that. I just need to work on my board. Okay, so now since line CD is perpendicular to BC, then by implication the gradient of line CD will be negative reciprocal of the gradient of line BC. And since line BC is 1 over 2, so minus 1 divided by 1 over 2 will give you minus 2. So the gradient of CD will be minus 2. Okay, so let me put that also in a square box. Guys, don't forget when two lines are perpendicular to each other, then the product of their gradients give you minus 1. So if you have minus 1, and if you have half times MCD, M subscript CD equals to minus 1, and you're going to have minus 1 divided by half, and minus 1 divided by half will give you minus 2. So now let's go ahead and find the equation of the perpendicular line to BC. This is the equation of the line parallel to BC. That is 2y minus x. So and we are going to have equation of a line perpendicular to line BC. Then we solve the system of linear the system of equation simultaneously. Okay, now to do that now let's just go ahead and so that is y minus y1, y minus. So before let's identify what y1 and x1 is first. This is CD. So since CD, then we'll be working with C here. So we'll be working with C here because we are dealing with CD. So that is minus 3 and 2. So x1 will be minus 3 and y1 will be 2. So y minus y1, that is y minus 2, equals to m into x minus x1. So minus minus 3 will give you plus 3. So I don't know why I put them here. Oh my god. So my m is minus 2, guys. What, they just banged it out. Okay, so that's why. This is my m is we have m already, so minus 2. So I can open up this now. So I have y minus 2 equals to minus 2x minus 6. So I want all the variable to be on the left hand side. So that will be y plus 2x. And all the constant to be on the right hand side. All the constant to be on the right hand side. So when you move minus 2 there, this gives you minus 4. So my equation, the system of linear equation I'm going to solve now. The system of the linear equation I'm going to solve simultaneously in order to get coordinate of D is the equation of parallel line to BC and the equation of perpendicular line to BC. And the first one is 2y minus s equals to minus 3. And the second one is y plus 2x equals to minus 4. So I'm going to do that in the next page. So let me go to the next page now. So the first system or the linear equation I have, the first linear equation is y plus 2x equals to minus 4. And this is the equation of a line parallel to BC. Then the second equation I have is this is second. Let me check, guys. I think that's the second one. The first one is okay. That's the second one. So the first one is 2y minus s. Okay, so let me just go back there now. Let me just leave this one here, or better still, let me just erase it because I think you guys would like to want to be precise. So let me write the first equation now. So the first equation is actually 2y minus x, okay, equals to minus 3. And that's the equation of the line parallel to line BC. And the second equation is y plus 2x equals to minus 4. And the second equation is the equation of a line perpendicular to line BC. So when you solve the system of the equation, the system of this linear equation simultaneously, this is equation 1 and this is equation 2. Solve it simultaneously. And what do we have there? Let me eliminate x. So to eliminate x, I'm going to multiply this one by 2 and I'll multiply this one by 1. So the this will become 2y minus x. Oh, what am I writing? Okay, I need to undo or just erase that so that it will be faster. Oh, that's a good one. Okay, times 2, that is 4y minus 2x equals to minus 6. Then this is a multiplicative identity, so you just it's going to give you the same equation back. Okay, so yeah, let's just equation 1 add equation 1 and 2. Okay, so this will give me 5y plus 0 equals to minus 10. So from here, y equals to minus 2. Substitute for the value of y in equation either of the equation, whether 1 and 2. Let me go with equation 2. So I have y. Okay, y is minus 2 already. So that is minus 2. So let me just write 2x here. 2x equals to, now this is minus 2 here. So when you move minus 2 to this side, to the right hand side, that's minus 4 plus 2. So this gives you minus 2. So in conclusion, your x is minus 1. So by implication, the coordinate of D, that is x comma y, will be -1 comma -2. Guys, don't forget that the system of linear equation we solve is AD, and let me just check it again. So that when you have um this is CD and AD. Okay, so AD is parallel, okay, and CD is perpendicular to this fixed BC. Okay, so now finally we are asked to find the area of the trapezium ABCD. So to find the area of trapezium ABCD, I'm going to use the coordinates. Okay, so how to find the area, how to find the area of rectilinear figures. Okay, so area of rectilinear figures that is given the coordinates, then you can find the area with this so I need A is 11,4, B is 7,7, C is -3,2, and D we just D now, and this is -1,2. So I'm going to write the coordinates out now, then I'll work with the coordinates. So let's just demarcate this now. I think I should be able to finish up this now. So guys, don't forget this video will be divided into two sections. This is part 1. So I'm going to round up the part 1 now. I'm going to make another video for part 2 in order to complete the remaining 2 questions, so that the video will not be too long, guys. Okay, so the coordinate of A is 1,4. Not 1,4, it's 11,4. So I just need to confirm that. The coordinate of B, is 7,7. I'll confirm that. I think I'm right. Yeah, 7,7. And the coordinate of C, I think something like -3,2. Yeah, I think I'm right. -3,2. And the final coordinate, that is the coordinate, is -1, -2. Okay, so now let me just confirm AB 1477 -32. So not 1, 11,4. 77 -32, 11,4. Okay, 11,4. Okay, it's 11,4, it's correct. Okay, so now, so guys, you need to note this now. And if you want to find the area of rectilinear figures, that is giving coordinates of any, you can find the area of any given polygon with given coordinates. Polygon from triangle upward. So triangle, quadrilateral, pentagon, hexagon. You just use this method I'm going to show you now. So you're going to write half, then absolute value. Absolute value meaning that in case your final answer here is negative, you're going to make it positive. So then you're going to rearrange this column wise as though it was so a column vector. So that is 11,4. So 11,4. Accordingly, A, B, C, D, because you have to find the area of trapezium A, B, C, D. So you start with A, then to B, to C, then to D. Then B is 7,7. Then C is -3,2. And D is -1,2. So guys, to use this method, you have to repeat the first coordinate. So whether you're dealing with triangle or any polygon is applicable, you repeat the first coordinate. That is 11,4 now in this case. So now next, this time around I need to change the pen color now, so that to show you what is going on here. So I'm now going to cross multiply. So 11 times 7, 7 times 2, -3 times -2, then this times this. So that's the first part. So let me work with the first part before I continue. So half, why did I do that? Half, then absolute value of then I can open the, let me use square bracket now. So 11 times 7, that is 77, plus 7 times 2, that is 14, plus -3 times -2, that is 6, plus -1 times -4, that is -4. Then you can close it now. Then minus, then open a new square bracket now. So you now you just the other way around now. Is this backslash or forward slash? Okay, let me just go ahead with this. So the other way around now, this times this, then this times this, then this times this, then finally this times this. So 7 times 4, 7 times 4, that is 28. So I'm working with the red now. Then plus minus 21. Then plus minus 2. Then plus minus 22. So I can close it now. Then end with your this now. So I now have half into, guys, you can just take your calculator now. 77 plus 14 plus 6 minus 4. Let me press my calculator. 77 plus 14 plus 6 minus 4, that is 93. So 93 minus 28 minus 21 minus 2 minus 22, that is minus 17. Okay, so minus minus will give me plus. So there I'm going to have half into 93 plus 17. So 93 plus 17, that is 110. Okay, so half into 110, that is 55. So guys, the unit is now, it's going to be, this is area, so that will be unit square, and that is the final answer. So the area of the trapezium, let me go back to the question. So the area of the trapezium ABCD is 55 units square. So guys, I'm going to call off the section for now. So this is the part 1, and I'll continue the next let me just quickly show you something now before I insert. So we have 2 more questions to solve, and because of our time, I need to divide this video into 2 sections. So I've solved CG1 and CG2. So in the part 2 of this video, I'm going to solve CG3 and CG4, which are much more demanding. So guys, at this point, let's call it a day, and do have a great day ahead. Please make sure you subscribe to my channel and click on like. Guys, take good care of yourself. Bye bye. Bye guys. Bye bye guys.